edition of Lab Rats. My name's Andy Walker.
I'm Sean Carruthers.
And this is the show that demystifies technology for you and your mom and your grandma and everybody like that. And we do it with some jokes along the way. Oh, sorry. I had to move
better.
My radio out of the way. Today on the show, we're going to talk about RF. Do you know what RF is?
RF.
What's RF? We're demystifying it.
Robert Ford.
No, it's not. What else do you think it might be?
Rigged flexion.
Rigged flexion, that's exactly what it is. Today on the show, we're going to talk about rigged flections. No, we're not. RF, radio frequency. You've probably heard the word, or the term, right?
Maybe not radio frequency so much. You've heard the word radio.
Yeah, but and these days, of course, geeks are using the word radio in all kinds of non-traditional ways. Not just like AM, FM radio, but radio waves and radio frequency. And so we're going to talk a bit about what exactly is this radio thing that's not AM and FM.
What is this radio thing?
Exactly. So, and we're going to use some fun food props along the way.
This is food?
Delicious. It's fruit by the foot, I think it's called. It's very delicious. This piece, I think, is banana flavored, and it's my favorite.
Well, don't eat the props before we get started.
Okay.
Hold on to that for a little bit.
Let's take a break. When we come back, we're going to teach you all about what is RF, what is radio, today on Lab Rats. So I bet you thought the radio was this.
He's a rebel. When I first met
and it kind of is. And it kind of has always been, back in the days when this was a primary form of entertainment for the household. But radio is actually a generic term, right, Sean?
It is.
And it refers to energy waves that move through the air that transmit data or content in some manner. So today we're going to talk a bit about what that is, and it's actually kind of a bit of a sciencey type of term.
It is.
Which we quite enjoy talking about, because of course we get to use our food demos.
Yeah. We should have had our lab coats on today.
I know, because this is dangerous stuff. We don't need to get this on ourselves.
All right.
Okay, so where should we start?
Well, let's put this down first of all.
Okay.
Now, as you mentioned, a whole pile of devices use radio, and they said radio sends data through the air, and it does it in waves. Now, when you've seen a wave going to the shore after, as you've said in the past, a speedboat passing by, it sends a lot of waves, and you see a wave pattern that goes by through the water. And radio waves are pretty much exactly the same thing. It has an amplitude, which is how high the wave is, and it has a distance between the waves as well. And
a wavelength.
A wavelength. It can compress or expand.
Right.
So now, depending on the wavelength and how high it is, how high the amplitude is, it will change what you're hearing at the other end.
Right. Hearing or what data you're receiving.
Or what data you're receiving at the other end. It's all about data. Whether you're sending something as a radio signal on AM or FM, whether you're sending it to your television, for example, that uses radio as well to receive over-the-air content, or whether you're doing Wi-Fi networking, which also uses radio to send it.
So let's go back to the very beginning. So.
Yes.
Radio, I guess, the concept of radio, using radio waves to transmit something, started way back, I guess, at the turn of the century. Not the most recent turn of the century, but 100 years before that, right, with a guy called Marconi. And he invented radio, or radio as we know it today, where you're transmitting audio through the air, right? And beyond that, of course, radio was developed over the years through the war and that sort of thing for transmission of audio, for voice. On demand, and then of course commercial radio. So what we know as AM, FM today, or so when we listen to music on or news or whatever it is in your car or on one of these devices themselves,
or shortwave, or any of those things.
Now that's evolved over the years, right? So we moved into the 60s and 70s. Television is transmitted through the air on radio waves, and of course we're really harnessing radio these days in the technology revolution for things like routers. Right, Wi-Fi, wireless fidelity,
Bluetooth headsets, even cell phones.
That's right.
Cell phones use radio as well to transfer information back and forth.
Right, there you go. Okay, so let's so that's the general definition of what radio is. And if you hear somebody who's techie talk about radio, recognize that they're not just talking about that thing that plays music and you tune into to get your traffic reports, right?
But Andy, if all of these things use radio, how come I can't hear my radio or AM/FM radio stations on my Bluetooth headset?
That's a very
or
good thing.
how come my wireless networking doesn't show up over there?
That's a very good thing too. And so let's talk about how we measure radio and well, we talk about things on the radio dial.
Mm-hmm.
So I think it's probably good. Well, let's start at the beginning with the radio stations.
Mm-hmm.
So when you change the channel on your radio, what's happening is you're moving the tuner, or the thing that receives the radio waves, on different frequencies or different channels,
Mm-hmm.
right? And so you're going through a particular band, right? So
Right.
a band of radio signals from one place to the next. And of course, commercial radio, or audio radio that we know, exists inside of this particular slice of the radio spectrum. And when I say spectrum, because we can go from way, way, way low frequency to high, high, high frequency.
Mm-hmm.
So should we explain that first?
Yes, I think
Okay.
the first thing we need to define is the unit of measurement, which is the hertz.
Hertz, okay. So what exactly is hertz?
So the hertz is one waveform per second. So if you're talking 1 hertz, you're talking every second you get 1. And if you're talking a kilohertz, you get 1,000 every second.
All right.
So, and AM radio is typically measured in kilohertz.
Kilohertz, right.
So when you see those numbers on your dial, that's basically 580 kilohertz.
Got it. All right.
And then when you go into FM, you're starting to go into megahertz. So that's 1 million hertz. So we can actually demonstrate this with our food demo here. So we actually have a wave that is a potential wave right here. So to get this thing going, we start wiggling it a certain number of times. And we're getting a kind of really lousy wave here. But you can see, so we're now talking a couple of hertz a second. So if we want to get into something faster, we just wiggle it faster. So now we've got more hertz. And then if we're going to go up to megahertz or kilohertz, and we've got to really wing this really fast, and it sort of breaks, and your radio doesn't work anymore.
Actually, yummy though.
Yes.
Right, so it's all about the speed in which you get the wave is created in the medium. And in the case of, it is very good. In the case of,
Biff was licking that earlier.
it's okay. Biff's like my son, right? It's like my child, so it's okay actually. Where was I going? You totally distracted me here.
It's about transmitting these
Yes,
things out at
through
a certain
medium,
frequency.
Right. So radio waves travel, of course, through a variety of different mediums. In our world, in the human world, they travel through the air, and in some cases concrete and that sort of thing.
Mm-hmm.
But it's an energy pulse that's been transmitted through the air and is being captured at the other end by an energy receiving device that decodes it into information. So whether it's a signal from your wireless router, or music's coming off of an FM station, or there's actually an energy wave using a radio coming out of your microwave too. You may not believe that, but it's very true. It actually has an antenna inside. It transmits radio frequency energy through the air that goes through the food, heats it up, and actually turns it into,
He just said the key word.
what's that?
Antenna.
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 Right.
This is how it sends it, how you send and receive information.
Very good.
So essentially, you push the information out. If you're at the transmitter end, you push it out the antenna at the frequency that we were talking about, however many times per second, or millions of times per second, out, and it just goes out from here, out to other places. So this is the transmitter, and then it would be received by this antenna at the other end. Now, to receive doesn't take as much energy as it does to push it out there, which is why when you see a radio tower out there or a cell phone tower in the real world that's servicing a whole area, it's generally pretty massive, and you only need a small antenna here. And this is why the ones on home networking devices like your wireless router or your cell phone not only have smaller antennas, but sometimes they're so small they can fit inside the devices themselves.
Right. Good. All right, well, before we wrap up this episode, let's talk a bit about troubleshooting radio frequency issues,
Yes.
because I think that's something that's going to be useful in the real world. Like sometimes you get into a situation where you can't receive something, or your cell phone dies. So what exactly is happening there? Let's talk a bit about that. First of all, if you have devices that are transmitting in the same frequency, you're going to get collisions, right? So if you, I don't know if you remember grade 10 physics. In grade 10 physics, there was a wave pool, and if you run a wave down a wave pool, like you would a radio wave, and you actually run another wave against it, it's going to actually disrupt the wave pattern, right? In some cases, if it's in phase, it'll actually cancel itself out.
Yeah, so 0. It'll come back down to 0.
That's right. So, so if you're having problems receiving something, you're either being blocked between you and the transmitter. So it could be concrete or metal. Metal is notoriously bad, especially a cage, like an elevator. It's notorious for blocking signals. So get away from the obstruction, or get outside where there's a clear view to the antenna that's transmitting. That's one way to do it. Number 2 would be to turn off a device that may be due to disruption. So for example, if you've ever been on your cordless phone and all of a sudden you're heating up a burrito and suddenly you can't hear the person on the other end because of static, it's because your microwave oven is actually transmitting energy into the spectrum at the same frequency or similar frequencies and causing interference. So that's the other way, is get rid of a second source maybe to make it creating disruption.
Yeah, no, that's in general, most of these devices use different parts of the spectrum. So these will use, this certain bandwidth of the AM spectrum, the kilohertz or megahertz. These will go into gigahertz, for example, with your router or your Bluetooth headset. And some of them overlap. A lot of things are being used in the 2.4 gigahertz spectrum, which is kind of unregulated, so anybody can get in there. A lot of them use different little slices, so they shouldn't overlap for the most part, but sometimes you do have little bits of overlapping.
That's true.
Because of that.
That's what you call the ISM band. It was a public piece of the spectrum. It's in the 2.4 gigahertz range. So what works in there is Bluetooth, Wi-Fi, microwaves, garage door openers in some cases, and some cordless phones as well. So that's a very, very busy part of the spectrum. Now, one of the tips that I give out on a regular basis when people say, hey, my cordless phone, I got lots of interference and that sort of thing, what do I do? Well, if you're going to replace your cordless phone, go and get the 5 gigahertz version of it, which shifts all that conversation that's going through the air on radio waves up to the 5 gigahertz spectrum. So it gets it out of that busy 2.4 gigahertz band. So that's band. So that's one way to resolve that particular issue if you have that at home. Of course, you could turn off your Bluetooth transmitter if that's causing problems. Baby monitors also work in the 2.4 gigahertz range. So it's get the traffic out of there or move things away from each other. Or get out of, or remove the obstructions as well.
Yeah, and one other quick tip on that is if you have the ability to change the transmission channel on here, like in routers you have 1 through 12, you can actually manually change that channel. Or, for example, one other thing that we use that uses radio is this wireless transmitter, and you can see on here it actually has a frequency listed here. I think it's 530 or 518. We use those 2 different things. So now if we were both on the same frequency with this, it would sort of start canceling out and we'd have bad interference, but I'm on one, he's on a different frequency. We can manually adjust these things, and you can actually do that with these routers as well. Matt?
I have a question.
Yes.
Yes, Matt.
Is this healthy?
Sticking straight at your eye?
Yeah.
Probably not. That's just a good point, actually, because there are some urban myths about maintenance men that climb into microwave dishes, which is radio frequency, to warm up and get themselves cooked.
Yes.
But the idea is you want to keep your key parts away from high transmitting antennas. So yeah, move the antenna away from your noggin there, Matt. It's probably not a good idea.
Now the good news is that anybody that's seen those other videos that are out there about, oh, you can use your cell phone's radio transmission inside to cook an egg or to pop popcorn, they're all frauds. They're hoaxes. Now there is some information. Anytime you have a transmitter and a Bluetooth headset like this, or your cell phone has a transmitter and a receiver in there, every time you're transmitting, it's sending some information out there. So you don't want to expose yourself to that any more than you absolutely have to necessarily, but it's not going to fry your head.
Right. Well, we don't think so anyway.
We don't think so.
At least there's no evidence right now.
Yeah. So,
okay, thanks.
There you go. That's the message from Dr. Carruthers and Dr. Walker.
We'll check in on how patient Matt is doing after. I think we have a problem here.
All right. Let's go to commercial.
Let's get a tripod.
We're going to get into picture time, and we have another download of the day from Miss Download.
Some fruit, Matt.
See you in a minute. Well, if the RF doesn't kill you or Matt, then the alarm will. Well, not the alarm, but the alert.
I thought that was the ambulance that we called for him after that last shot.
Stop it!
Sorry, Matt. Anyway, fun with RF and other devices. So, before we get to picture time, and
I know you want to play with this again. I'm taking it away from you.
Before we get to picture time, Miss Download is here again with a download of the day. So why don't you go and see her for a bit, and I'm gonna see if we can get my radio back. And when we come back, picture time.
Hi, welcome to Miss Download. I'm Cheryl Poirier. So I'm sitting around the new web TV mecca known as butterscotch.com, and I'm talking with the Lab Rats guys, and they're talking about radio frequencies. And the conversation went from radio frequencies to the aluminum foil hats that people used to wear because they were afraid of radio frequencies. And I thought, I'm just going to take a detour from my normally really helpful downloads to bring you something about aluminum foil hats. Wondering, of course, if it was out there. And of course, everything is out there. I bring you the aluminum foil deflector beanie. Yes, you will need, obviously, aluminum foil and Scotch tape. And I'm going to show you why, because this is fabulous. You have to get five feet of aluminum foil. Now, the thickness of the aluminum foil is perfect. Oddly enough, the thickness of Alcan aluminum foil is perfect for your beanie. You fold it up, cut it, and fold it up, and then you actually Scotch tape it together. And this is my beanie that I made yesterday. My head is now safe from radio frequencies. And I know what you're thinking, hey, Miss Download. Yes, you know what? It is a download. You can download it in an easy-to-print PDF format right down here, which is awesome. And I highly recommend that you actually download the PDF, because it might take a couple tries for you to get your deflector beanie right. Sadly, it does. Now, the Scotch tape is not only to hold the beanie together, but it's also used to hold the beanie to your head so that it stays on in all kinds of weather, apparently. It also hurts your hair, just in case you were wondering. You can notice how you can use a lot of tape to actually secure it to your cranium. I just used 2 pieces. One thing that you really have to be careful about, and I didn't know this, is the shiny side. The shiny side has to be out, because it's the shiny side that deflects the radio frequencies. If the shiny side is in, it can actually fry your brain, apparently. Some guy did a study and fried his brain. I also found a gentleman on the internet who, for a small fee, will make a beanie for your cat. So I thought that's interesting. So I made a little beanie for Biff. And here's Biff in his cute little aluminum foil beanie with the shiny side out, and his little pea brain is protected, much like my little, no, it's not a little pea brain. I have a little beanie. It's protecting my very large brain. So here you go. I promise my next show will be helpful, but this one is just for fun. Your very own aluminum foil beanie. Get one. Be cool, like me, Miss Download. Cheryl Poirier at butterscotch.com. See you later.
I see why you like this.
It's no fun when I don't have control over it.
No. I'll just put it over here.
Okay, good. Oh my God.
Poor thing.
Poor thing. All right, so time for pictures. Time for pictures. It's picture time here on Lab Rats.
Yay!
Yay! And this is the part of the show where we show you the pictures that you sent us of you, so you can see you on the show, or something like that.
Yes. You can send them over the air wirelessly, all that. You can send it
Using
over a
RF.
wire. You can, use that radio over there and listen to it for a while, and then send the picture.
Right. So who do we have today, Mr. Carruthers?
Well, first up, we have Adrian, who is from the Philippines. And Adrian is the gentleman on the far right, I believe, with the T-shirt Gothic Room.
Gothic Room. And who are these other picture people? Is that his brother and his sister and his cousin and his waiter? And
That's his bookie.
his bookie?
And someone they found, I don't know, he didn't say, but he told us this is him. And all these people, don't make me name all these people off the top of my head.
I'm always curious, right? I'm always curious about who's in the picture. So if you're going to send us pictures, don't forget to name everybody in the picture. And you notice that they've been ignoring me lately because I've been asking this on an ongoing basis. Where are you? What's in the picture? Who are they? What's the relation to you? And any other salient facts that would amuse us.
Their complete personal history.
Yeah, we don't need
their occupation.
Yes, their social insurance number. No. Okay, good.
I think that's enough for that.
That's enough of that. All right, next.
Thank you, Adrian. Next, we have from our viewer, Dan. And I think Dan's in Trinidad and Tobago. This is his cat, Doris.
Based on the tropical locale outside, I would say it probably is a Caribbean island.
Yeah, and based on the email. This is all I have to go on that. So, but again, tell us where you're from, please, and let us know.
Beautiful cat, by the way.
It is a beautiful cat.
Yeah.
Yes.
Okay, good.
And one last picture. Remember a short while ago we had Grandpa Chris and grandson Jack. Jack was Chris's IT manager.
Right.
And it looks like Jack has now helped Chris pick out a new set of wireless headphones.
Very nice.
After watching our episode on headphones.
Ah, there you go.
And also after watching this previous episode on wireless and radio technology. Wireless headphones use radio too.
It does.
It's true.
Fantastic. I love how you wrap it all up. You bring it all back to something salient.
I want some of this fruit by the foot too.
All right, you have some of that. Open some of them for me. In the meantime, if you want to send your pictures to us, don't forget to email them to...
This package is really untasty at labrats.tv.
Yeah. Or...
feedback at labrats.tv.
Right, and preferably the latter. And you are now going to find us on a brand new website called butterscotch.com. And you won't even, not just find lab rats, but a whole bunch of new technology shows. This demystifies technology and entertains you and teaches you all about the things you need to know to get by in this technology-filled world.
Yeah, but none of the other shows flip fruit.
Well, we are the best show on butterscotch.com for sure. All right, so check us out there. Amber MacArthur's got a show on it. Miss Download has her own show there. And lots more technology content where that came from. So fire up your web browser, butterscotch.com. Okay, are you done yet?
No.
No, he's not. All right, well, thank you for pushing play this week and watching us, Lab Rats, on whichever screen you happen to watch us on. My name's Andy Walker.
I'm Sean Carruthers.
And we'll see you next time. Fruit by the foot. Yum.
Are you ready? Try this at home.
All right.
So when you go upstairs to the loft and see Miss Download, she's got a download of the day. And when you come back, we're going to show you some pictures of the people out there in Lab Rats land.
Hey, Ding Dong, we just came back from her.
I think somebody just had a brain fart.
Oh, oops. Sorry.
You want to see some pictures instead?
We're coming back from Miss Download. Okay.
Let's do it again.